All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. Tonight, we're going to kind of pick up where we left off last night, but I did a little bit of thinking while we were away and kind of came to the conclusion that there is a little bit more that we need to do to make the scene work really the way that we want it to. So, we're going to go over that tonight and take a look at some of the stuff that we need to actually handle to make all of that happen. And we actually need to perform quite a bit of refactoring in the code base. And it's something I've been kind of avoiding, but I think I can't avoid it any longer. So that is what we are going to be doing tonight. Doc Lock, good to see you. Welcome. Appreciate you being here. Let's see. So, yeah, we are simulcasting over on the Twitch and YouTube side. So, Titty Bite, thank you for the follow there. Appreciate that. You were finally first into class, Doc Lock. Awesome. Yeah, that's good. Goals, right? I don't know if I was ever first in class. So, but yeah, we are simulcasting on Twitch and YouTube. So I do keep an eye on both chats. That being said, I do want to take a quick second before we kind of jump into things here and give credit where it is due. And that is for the supporters of the channel, starting with the partners who are the highest tier of subscription over on Patreon and YouTube memberships. Those are Gaby Bashir and Gerbolis Inc. I'd also like to thank everybody else listed here under the supporter section. They are a combination of the other tiers of support over on Patreon, YouTube memberships, and Twitch subscriptions. So thank you guys very much for your support. It is greatly appreciated. I would also like to thank all the viewers who are either on the Twitch side or the YouTube side. I appreciate you guys, each and every one of you. Without you guys, none of this would be here, right? So thank you very much for being here and interacting, right? Doc Lock, thank you for the 1 bit. I appreciate that. Okay, so that all being said, this is an interactive stream, so I try to keep an eye on the chat and answer questions as they come up. So speaking of which, you are asking if we use Zig. I do not use Zig on here. I use C, actually. But Zig can pull in C. So I know that Spiro and I have been talking about potentially collaborating at some point where maybe he's able to pull in parts of my engine and use it. For some of the stuff that he's doing, since Zig can actually pull in C code. So that should be pretty interesting when we get to that point, right? Blind Kamikaze, welcome, first time chatter. Good to see you here. Where's your name? Where is it? You know what? Good question. Sometimes my update script doesn't capture the latest updates, so I will have to run that again later, because I'm guessing it just didn't, it doesn't like always pull the updates, and it's kind of hard for me to tell, so that will be correct on the next stream, guarantee it. I will make sure it's there. Sorry about that. Yeah, no, it absolutely should be, right? You have a point, right? It should be there. And if it's not, then it definitely should be. But yeah, my script does, it's not perfect, unfortunately. So, Diamond, good to see you. Good evening. Welcome. Let's see. Zig versus Rust versus C for game dev targeting WASM. Thoughts? So I actually haven't I haven't used Rust or Zig enough targeting WASM to be able to really come up with a comparison on that, right? Like, I don't think I can really speak on it. I'm not really qualified, I don't think, because I haven't used it, right? So, did I settle on a name for the resource loader? No. But I did a lot of thinking offline because there's actually some other stuff that I kind of got thinking that we really need to do, which I think will actually inadvertently resolve that issue. So, let's see. In a few weeks, this code will look like a game, or am I brain farting? So, yeah, I mean, technically speaking, if I were to run it now, like, you can kind of see an environment. I've been doing a little bit of coding offline, though, just to kind of map some things out in my mind. So I actually don't know if it'll compile at the moment, but we'll compile it and try it. Call it deep thought. Yeah, exactly. That's... I could name it that. But then users of it would be like, what? So, all right. What we have is I've made a couple of changes. First off, I went ahead and cut a quote-unquote release, or cut off 0.6, version 0.6, because we actually had all of this stuff in 0.6, and I figured that was enough, right? And the other half of that is because the set of changes that we're going to do coming up is actually kind of a big set as well. So I wanted to go ahead and break off a new version so that we could do that. So I've gone ahead and done that, created the new branch for it and everything, and tagged 0.6 in the main branch. So if you get the main branch now, you'll be basically at right before this 0.7, right? So we're on 0.7 now, and all we've done in that so far is we renamed simple scene to just scene. So there is no simple scene anymore, it's just scene. And part of that is because of some of the stuff we talked about last night. We also moved it and its loader to the engine core and removed all the references from the testbed application, right? So it's actually part of the engine core now, as it probably should have been, right? I kind of went back and forth on that a couple of times, but that's where I landed. That all being said, what I got thinking about last night was basically this whole deserialization thing that we were talking about. Serialize, deserialize. And then I got thinking of, well, maybe we should have nodes that contain a few different properties, like a unique identifier, a handle ID, things like that, and potentially a name. And then I got thinking about, well, maybe we should have a language that's a little bit more expressive so that it could be nested. And then I got thinking about, well, that still doesn't solve the parenting issue that we were having, where we don't have a way to actually look that up. And that's because our transforms are part of our meshes, and our meshes, or transforms, know nothing about what actually owns them. And we have no way to actually tell what is a parent of one mesh to the next, right? The only hierarchy we had was sort of that transform hierarchy. So I got thinking about scene graphs and transform hierarchies and various graphs of that nature, and it kind of led me down the path that we really need handles for stuff. We shouldn't be using raw pointers for stuff, because I can just see all of the issues that are going to arise from us using raw pointers for all these things. And so that kind of led me down the path of we need to do some major refactoring. Because there's several things about the code base that really ought to be fixed. So that is what we're going to be talking about tonight. Let's see. Adixon. Hope I pronounced that right. Thank you for the follow. Appreciate that. Welcome. P.S. Best beard I've seen yet in the dev category. I appreciate that. This is about 6 months of work. Ish. Maybe 5. Kamikaze is cringe, my bad. Nah, no worries. Alright, so let's see. Trying to start a debate, more or less. It's a topic but you're pretty fascinated with right now. Yeah, like I said, I used Rust enough to realize that I didn't like the things that it was forcing me to do with my memory, right? Like, I don't like being told to do what to do with my memory, which is why I don't use Rust. I have not tried Zig yet, so I can't really speak on that. UUID time. So we actually already have an identifier set up. And this identifier is just a U64, right? But it's an actual unique U64. So when we create an identifier, and this is all it contains for now, it's just a structure with a U64 in it. But I did this in case we wanted to ever put like metadata with it of some kind. So if we go into identifier create, let's see. We basically have this Mersenne twister randomization that we create, and we seed that based off of the current time, right? And so we use that random number generator to generate a random number that's 64 bits, guaranteed to be random. And that is kind of our unique ID, right? That's more or less what we're using. So I'm not going to go into the implementation of this. We've already kind of gone over that in the past. But that's what we're going to use as the basis for part of our handles. So the reason that we want to switch to a handle system for things is I'm actually going to use, let's use meshes as an example, right? So let me switch the color here. So let's say that we have, a array of meshes, right? So we have multiples of these things, right? And it's just a single array, a flat array of meshes, right? That's owned by some system somewhere. And essentially the way that we get a pointer to the mesh is we take the address of one of these things. And that winds up being our mesh, right? And so let's also say that our mesh is maybe a dynamic array, right? So maybe in this case we've hit 5, right? And we need to add another one, right? So our array is only this big, right? But we need to add another one down here. Well, in order to do that, we actually have to reallocate, right? Now, ideally, we'd add more than one at a time, but for the sake of an example, right, let's say we just have to reallocate right here. Well, the problem with this is the address of this mesh array can actually change on a reallocation, right? Because if our allocator does not have enough room to expand the memory this way, when we try to get more memory, then that means we have to go somewhere else to do it, which means the address of this array has now changed, right? And what that means is if we are having any pointers out there to this first mesh, right, that is no longer a valid address. So any pointers we've taken from that are now invalid, which is not an issue we've hit yet, but it's an issue we're going to hit. And the same can be said for really any type of resource, right? So if you think about textures, if you think about materials, things like that, we really shouldn't be taking pointers to manage these things, right? That's not really the way that we should be doing it. And so what we're going to do is we're going to have handles, right? And a handle is going to contain, I'm thinking for right now, 2 properties. So the first property is going to be what we're going to call what did I call it? What we're going to call the handle index, right? So the handle index, right? And what this is going to be is a lookup into an array of something, whether it be meshes, whether it be textures, whether it be whatever, right? And then the second thing is going to be an ID, right? And so the idea here is that this guy will look up into an array of something, right? And then we'll be able to obtain a pointer to that thing if we need to. But this ID, this unique ID, should also be stored by whatever it is that we're indexing, right? So in this case, a mesh. And the idea here is that we should be able to look at whatever we're obtaining a pointer to and say, does the ID of that thing match, right? It should be unique, right? But our handle and our ID should match. If they don't, then we know we have a stale reference, and that's one way we can actually determine that, right? And it's so at that point, we can assert on that or something like that. Essentially, whenever we go about actually destroying, something like this mesh, when we destroy this guy, we should also destroy the handle to it, right? So, we can call that a bunch of different things, but more or less what I'm thinking is, we have the handle index and then we have the ID, and that whole thing encapsulates a handle, and those handles are what we use to work with something. So a lot of our APIs are actually going to have to change, and a lot of our systems are going to have to change in order to make this work. But I think it's a much more flexible system going forward. The other thing that it allows us to do is look things up simply by handle, right? So we don't necessarily have to keep these mesh pointers around, right? If we need to update the mesh, we update the mesh system that tracks it to take in a handle as the argument, not a mesh pointer, right? If we're dealing with textures, we take in a texture handle, not a texture pointer. And there are a couple of exceptions to this that we'll talk about, but that's kind of the direction we're moving in, right? Let me just catch up more here on chat before we move on. Zig is more of a C replacement, and Rust is like something C++ replacement. Again, I can't really speak to that. Yeah. Let's see. I usually call ID version. I usually give it 24 bytes. So there is another aspect of this that I think you're alluding to. We have something called generation. Textures have it, meshes have it, and it's an internal, essentially, counter that increments every time we make a change to it, right? So if we reload an asset, or something has changed in the data of that asset, like we write to a texture, we also increment the generation, right? And then we can match on that if we need to. And one of the things, like for textures, for instance, we can determine whether or not we actually need to rebind a texture, for example. Let's see. The system you described is kind of like entity systems. It's not, though, because the difference... Well, I mean... Not really, right? Because entity systems, an entity is essentially a bag of handles. Is essentially what that is, right? Whereas we're not really dealing with a bag of handles here. So it's not exactly the same thing. The structure of the ID, where you have a handle ID and then or a handle index and an ID, a unique ID. I mean, really, what it is, it's I would say it's more akin to like a smart pointer, right? It's like our version of a smart pointer, only instead of pointing to direct addresses in memory, we're using numbers to represent that, right? So, yeah, I mean, I see where you're going because I've seen like some of those talks that talk about, an entity has, a list of IDs that it uses for its components and things like that. And you could certainly use this system for that too. In fact, when we go to set up our ECS plugin, we'll do that. But the system itself is not necessarily that. So the way that this is going to work is, let's see, I need those. Okay. So the way that this is going to work is, let's say we have our array of meshes over here, right? And I'll redraw this because that other one's kind of a mess, right? So let's say we have our array of meshes over here. Right? Let's say we've got 4 of them, whatever. What we're going to do is our handle index is not going to index directly into this array. And the reason for that is because we don't necessarily want to be retrieving raw pointers for these things. And so what I'm thinking is that each one of our systems, so to speak, like the thing that holds our meshes, the things that hold our texture, we are essentially going to have an index of IDs, right? That we can... Oh, wait a minute. Do I need to do this? I might be conflating two things I was thinking before. Give me a second. Actually, I might not need to do that. We might be able to actually do that. Trying to think of a reason we wouldn't want to do that. I thought I had one before. Now I can't think what it is. Let's try this way first, right? And see where we wind up. Yeah, because I went through, like, I did a lot of reading on this today and kind of went back and forth on a lot of different designs and systems that I could potentially go with, and I kind of settled on like a mixture of a few things that I found. So I think our handle index should be able to index into this array just fine. Oh, I remember why. I was thinking we wouldn't do that. So this is an actual array of meshes that exists here, right? Not an array of pointers to meshes. So we can't exactly tell if one of these things exists based on whether or not it's a null pointer, right? So one thing that we could do, there's a couple ways that we could handle this. We could have like another layer of indirection, right? And this was something I hadn't really decided on yet. We could have another layer of indirection, which would just be an array of essentially indexes, right? And that index would either be this index or invalid ID. And for any entry into this array that is invalid, right, they would just be a one-to-one mapping. For any of these that are invalid, right, that means that a mesh doesn't actually exist at that location. So we could either have like a separate array like this, or we can encapsulate that data into our mesh structure in here. And that was where I hadn't really wound up yet, right? Because what I don't want to have is I don't want to have an array of pointers here, because that just seems like asking for memory fragmentation, right? We definitely want to keep all the data contiguous, so we don't want to have an array of pointers. So we can either have this sort of lookup table, if you will, where invalid entries are just invalidated here, or we can have an internal thing on the mesh itself on that structure that we can go by. I'm leaning more towards that, so we could just look at this and say, hey, if the thing is invalid ID, that means it's not loaded, and or is not valid, right? And at that point, anything that is asking for a pointer to it, you just wouldn't return a pointer to it. Although for meshes, I can't think of why you would actually want a pointer to anything, right? So we're trying to kind of get away from pointers to things. The exception to that is like in a renderer front end, where we are doing something like texture create, right? Or reading or writing data from a texture, or something like that, right? In this case, I think it's fine to pass a pointer to that, right? Because right before we make this call, we could essentially get the pointer at that specific point in time, and it should be safe enough to pass that through, right? But anything that's essentially not the renderer probably shouldn't have a pointer to a texture, for example. And so I kind of went through the code base before and built up this to-do list here for our refactor, and this is kind of what we need to do, right? So that is more or less the direction we're going to go tonight, at least to start on. Apotham, good to see you. How's it going? Welcome. Singy, hello. Good to see you. Welcome. The A house. The same issue with STD vector. Do you mean the memory fragmentation, or I'm not sure which thing you're referring to there. Or are you talking about the reallocation when we resize an array? Because yeah, that's essentially what we're running into, right? Let's see. Christoph, I find that having stable pointers is a good idea even when dealing with handles. It lets you expose pointers to the resource themselves without having to worry about the user keeping the pointer for too long. Too long can actually be a very short time, exactly. Calling get and then some seemingly unrelated function could add some entry somewhere, making the pointer invalid, exactly. And that's one of the reasons I want to get away from pointers, right? So I want to kind of establish a rule when we're dealing with resources, resources being anything like a mesh or a texture or anything like that, that we deal specifically with a handle. And the only time that we ever actually pass a pointer to anything is a pointer to the renderer if and when it needs it, right? And that's purely for a single call to do something right then and there, and then it's gone, right? And that's really the only thing we should be using like a texture pointer for. Been an interesting day. After I coded a nice OpenGL renderer in CPP, my friend turns around and decides to rewrite a rewrite to Zig needs to happen. So you guess you're learning Zig. Here's my question though. Why? If you already have something working in C++, like, I don't know. I think sometimes there's limited return on things like that. Like why switch away from something that already works and that's already written? What are the benefits of doing that, right? And what would the benefits to switching be versus the drawbacks? At least to me on the surface, I would think the drawback would be rewriting the whole freaking code base, right? That's probably not worth it, in my opinion. So, yeah, I don't know. I mean, if you have to have your user code in Zig, then maybe create an interop layer or something, right? Rewriting things always introduces more bugs than you started with. Not only that, but also doing it in a language you're not familiar with is also going to do that. So, yeah, I don't know. I would avoid that if I were you. I would push back on that for sure. All right, so we'll talk really quickly. I guess since we're kind of talking handles, the way that I'm thinking about this is, and like I said, I was just kind of putting some things out there, putting some things in code to kind of see what sticks. Is our handle would essentially look like this, right? So our handle index would just be a U32, and then we have our identifier for our globally unique identifier. And the identifier would also be stored in whatever this is a handle to, and we'd use that to verify that they match. And then I started kind of thinking about a handle table, right? Because a handle is really just a lookup into an array. And so it might be nice to have a lookup table for this. I'm not 100% sure we're going to wind up using this or doing it this way. But I know this is kind of a pattern that's kind of repeated a lot in the code base too, where we kind of have an array of things and we loop through that array of things to check the ID and see if it's a valid ID and that kind of thing. And so maybe it might be nice to have something like this that does that instead. I'm not sure yet. Let's see. You're not a fan of it, but I think you hit a breaking point of just being tired of CPP. Yeah, I don't think that's a good answer either. I don't think that's a good enough reason. You're no fan of CPP, but it's his project. I mean, yeah, I get that, but like, you're still doing work for him, right? So you have a voice in that on some level. At the end of the day, it doesn't really matter what it's written in, right? That's not gonna, generally speaking, that's not going to affect things unless it's like super specific, right? Unless you're trying to render like AAA graphics or something like that, like, or trying to get it to run on a PlayStation or something. It's probably not going to matter what it's written in. So why not just stick with what you already have, literally, instead of re-rolling it again? Like that seems just kind of crazy to me. But to each their own, as Diamond says. Yeah. All right. So I'm not 100% sure if we're going to use this K handle table, but the K handle is more so what we're going to do. And then each system will essentially have the ability to create handles and translate from a handle to a pointer to an object if you need it, and or to make that translation internally if it should be obtaining a reference to something, right? So that's kind of the way that we are thinking about going with this. We're going to have ads here, so I'm going to wait to actually jump into this until after ads are done. Let's see. And Christoph, I will have to get to your messages once we're done with ads, because I think ads are going to be popping up here in just a second. You are also referring to a bit to the fact that keeping pointers stable is not that hard and does cause very little performance impact. We could just have an array of separately allocated blocks. That's true. Then accessing the element is just one pointer dereference more, and the fragmentation is very low since we can size the bucket to something reasonable. And that's certainly one way to get around that, right? Oh, we have ads. So for those of you on the YouTube side and those of you on the Twitch side that can still hear this, if you don't have ads currently playing, is I like to pause the stream whenever ads play on Twitch. And that is once every 30 minutes for 90 seconds. And the reason that we do that is because we don't want anybody to miss content, right? The ads are just a full screen thing that comes up. You can't see what I'm talking about or hear what I'm saying. So for those of you who are new here, we like to just make sure that the stream is on pause so that nothing gets missed. That being said, we do have a timer now that is on the ad screen, so you guys have an idea of how long we have. So if you need to get up and get some water to hydrate, like I'm about to do, you've got time to do it, right? So we've got about little under 30 seconds left on ads. Almost done with ads. Max, good to see you. Welcome. Got here early. Yep. It is a little bit early. We got a little bit of an early start tonight. All right, cool. Ads are done. So, let's see. However, still moving away from pointers to handles is a very good thing for almost everything, I find, for debugging reasons and general control. Exactly. And that's one of the reasons we're going to be doing it, right? Because it makes it a lot easier to trace what's going on as well. Okay. So, I don't know, like I said, I don't know if we're going to look up this table or just sort of re-implement this per system, which is what I'm thinking we're probably going to wind up doing. So each system that'll wind up using these handles will have to have a way to convert back and forth between handle and pointers to whatever data it is internally. Whether that conversion is exposed depends on the system, right? For example, a mesh, we probably aren't going to need to have a pointer to a mesh, right? A handle should be fine. There's nothing there that we should need to do about that. Our texture system is largely going to be the same. So what I did is I got thinking about this a lot today, actually. And actually, this is not all 100% accurate, but I was initially thinking about a global handle system, but we actually don't want globally unique handles. And the reason for that is each individual system is going to have its own method of handling handles. And we don't really need them to be unique, like globally, right? They only need to be unique per the system that the handle is for. So I think it's perfectly fine to have per system handles. So we should probably say per system, let's say unique per system handle, which issues. How do I want to word this? Let's see. For each system to identify a resource. These handles would be linked to both a resource array of some sort and an index element. Okay, so I don't think I'm going to do that part. So I'm going to say these handles would be linked to a resource array of some sort. And index an element within that array by a structure that holds both. I think that more or less makes sense. All right, so we have that. And then let's see, create a new XForm structure and system that uses handles and can manage dependencies and updates internally. So this was kind of another thing that we briefly touched on last night when we were talking about the scene stuff, where the only hierarchy in a scene that exists right now is the transform hierarchy, and it does that with pointers, right? So that's not ideal either. So what we're going to do is we're going to sort of deprecate the current transform system, or the current transform, and we're going to create a XForm structure and a system around that more or less handles the same thing, but it uses handles and can also handle all of its dependencies and parenting and updates and stuff internally, so that we don't have to have all the systems all over the place doing that stuff, right? So we're going to do that, and then we are going to remove the transform pointer from the mesh, because that shouldn't be paired. And then we're going to update / create some systems to use handles, right? So we're going to create the XForm system that uses handles. We're going to create a mesh system that uses handles. So we don't have a mesh system currently. We're going to create a mesh system that owns these meshes. We're going to convert our material system to use handles. We're going to convert our texture system to use handles. So basically everything that isn't a call to the renderer should use handles. Same thing for the shader system. Our shader is just going to work with handles, right? So anything that isn't a call to the renderer is basically going to use handles. The lighting system, the skybox system, well, the lighting system already exists, but it needs to be converted to use handles. We need to create a skybox system that uses handles and a scene system that uses handles. And then after we get all of that done, right, at that point, once we get those things in place, we should be back to a running version of the engine, at which point we will refactor the simple scene loader, which is now just the scene loader, to a version 2 that is going to have much more expressive syntax and allow nesting of objects, right? And I put this here just as sort of a reference to kind of remind me of what I was thinking of there, right? I don't know exactly what syntax we're going to work with, but we're going to try some stuff. And then we can get back to the serialization, deserialization stuff, because we will be able to handle this a lot better and write some of the different graphs that we need internally using handles instead of pointers to stuff, right? So that's kind of the goal. And so part of the reason behind this is, as you might imagine, we can't have like the scene owning meshes, right? Which it kind of currently does. Just like the scene shouldn't manage or own textures or materials, it shouldn't be doing that with meshes either. And so that should be managed by a system outside of that that is responsible for handling those things. So a lot of separation of concerns that we're going to be doing. Tammin, good to see you. Tamindua. Anteater in a suit. I remember that. How are you doing tonight? Good to see you here. I have an update for you, actually. So, Tammin, if you look under the channel point rewards, right, the coffees, there's a new entry there that costs 100,000 credits, right, or coffees rather. And so what that's for is basically once you save up 100,000 of those things and you redeem that, you essentially DM me on Discord or whatnot, and however you want your name to appear, you will get a permanent entry in a credits file on the Kohi engine. So it'll be like a special thanks section for anybody in there, because it is a unique form of support being here on the stream and supporting me this way, right? So in addition to the other things that we have, that's kind of a new redeem I put in place. I'm still thinking of some other stuff, but that's one that I thought of yesterday actually. So asset manager time, doing all right. All right, cool. Asset manager is always fun. Master Snoods, hello, welcome, good to see you. Let's see. I always like separating systems out to not be so tangled together. Exactly, and that's what we're going to try and resolve here. You like it? Good. Yeah, I was hoping you would like that. That's awesome. All right. Let's see. So will the scene own anything? Yes. So the scene is going to own a couple things. It's going to own the vertex and index buffers for one thing, right? So we are going to have scene-specific vertex and index buffers. And the reason for that is because I'm still thinking at some point we might want to actually support multiple scenes, right? And so we want to separate the memory out between those two. You're currently at 35%. Nice. The scene will also contain in it several different types of graphs, depending on what data we're trying to query, right? So we're going to have a like a hierarchy type of graph that's going to give us object hierarchy, and that's basically going to be a hierarchy of handles, right? And then we're also going to have I guess you could call it like a hierarchy or transform graph, right? So that we can get that information as we need it. And then it's going to have a couple different types of spatial partitioning for making queries about different objects, where they are in relation to other objects in the scene, things like that, right? So the scene is going to basically be more or less like almost like a relational database, kind of, sort of. You can kind of think of it that way. Of course, we want to support multiple scenes. Yeah, because the more I think about it, like it might be nice to actually have that kind of support, right? And I don't know that we'll necessarily use it, at least not in our first game. But I don't want to kind of code ourselves into a corner and say, "Oh, we'll never do that," and then have to rewrite the whole thing again, right? So that's kind of where we're at on that one. Okay. So, I think the easiest one to start with is going to wind up being this XForm system, right? Because there's not anything hooked up to it, so we can really kind of get a feel for how handles will work with a system that uses them, right? And so we're going to have an XForm that has the capability of parenting and child support, right? Okay. Multiple scene support equals easier prefabs. And that's kind of what I'm thinking, right? Because essentially a prefab is just going to be a little mini scene, I'm thinking. Right? So if we have a scene that can then be imported into another scene, right? Like that's... And then, obviously added to the object hierarchy. If the scene itself has its own handle that could be... given a transform and then fed into the hierarchy / transform graph, right? Then it just kind of makes sense, right? Okay. So XForms. So we're going to be replacing transform, right? With XForm. So we're going to put it, I think we're still going to put it, but it really needs a system, right? So I don't really know that it belongs in math. I don't know that it belonged here in the first place, actually. So I think I'm going to do... I think anything that uses XForms is going to need the XForm system. So we'll do XForm system.h. And that's where we'll just sort of declare everything, right? So so we'll say XForm system H. XForm system H. All right. And for this, we're going to need math. Math. Do we want math types? Yeah, probably math types for now. All right. Why is my syntax highlighting, like, freaking out? Oh, it should be if not def. There we go. Okay. So, if we take a look at transform H, which actually, ironically, the transform isn't even declared here. I think it's on math types. We more or less are going to use a similar structure. We're just going to kind of change some things up a bit. All right, so let's kill that, put this here. And we're going to call this xform. All right. And same thing down here, xform. All right, we are also going to include core k handle. So our transform is basically, or our xform we'll say, is going to have position, rotation, scale, as you would expect. We'll keep the dirty flag. We're also going to cache the local matrix, just as we've always been doing. We'll keep the determinant. What's going to go away is this guy. So there's two ways that we could do this. We could put a handle to the parent here, or each transform can have a handle or a set of handles to its children. I still think the parent system makes sense. So instead of having this, right, we're going to have a k handle. K handle to the parent, right? And so this is going to be, instead of a pointer, a handle to a parent xform if one is assigned. Now instead of null, let's see, how should we handle nulls in this case, right? So we have our k handle over here. So maybe we say considered null if equal to invalid ID, not the U64, but right, like if it's invalid ID, we're going to consider it null. Maybe that's what we do. Right, so in this case, we'll always have this handle here, but it could potentially be null. Invalid handle equals -1. That's what invalid ID is, actually. So invalid ID is essentially, these are, we're using unsigned integers here. So essentially what we're doing is instead of saying 0 is invalid, we're saying max U32 is invalid ID. Which essentially, if you set handle index to -1, you would get that too. So it's essentially the same thing. Let's see. Diamond components. I wouldn't count prefabs as components, though. We are going to be doing a ECS, though. So don't worry about that. And all of you fans of ECS out there, we are going to be making an entity complication system. And you can bet your bottom dollar I'm going to put that in the comments as to what that is. PC Ho, thank you for the follow. Appreciate that. Welcome. Let's see. It's 2:45 a.m. here, so take it away, Bob Ross. That's an interesting one. I don't have quite the afro to make that work, though. His afro game was very strong. Some happy little accidents and bugs here. Some iron blue fonts, a happy struct. Give it some array friends. And spank the mouse dry? Is that what? From like that is the weirdest comment so far, but by far that you've left for sure. You're halfway there to ECS already. Not really. I mean, kind of, but not really, right? Because again, we're not going to have we're going to have our scene is going to have nodes. It's not going to have entities and components, right? It's going to have nodes which have handles in them. That's essentially the way it's going to work. So, the ECS is something that's going to sit on top of that and act as sort of the relational lookup for that. But that comment beat the suck my dictionary by far. Yeah, exactly. Which was still pretty hilarious, honestly. Okay. So, I probably should have kept open this, because there are a bunch of functions in here that we do want to keep, right? But these are all sort of the pointer versions of these things. So what we'll do is we'll take a copy of all these things and put them here. And we're going to do some gross find and replace, right? So we'll do transform, and we're going to replace that with xform globally, right? And so the biggest thing that we're going to be changing with all of this, because I don't think we're not generally going to need a pointer to this thing, right? We theoretically could just get the individual parts from it. Although for this, I might still allow for a pointer, maybe like a const pointer. So let's see. So for xform create, for that one, I don't think that we need to take in any parameters. I think that's fine. Oh, there is one piece I forgot, actually, which was the unique ID portion of it, right? So we have a identifier, unique ID, right? And that is to a globally unique ID used to validate the handle against the object it was created for, right? So we need that. And then let's see, xform. So instead of this, we're going to do essentially a k handle, right? We'll return a handle. So that's essentially what all of these are going to do. So in this case, so we return a handle to the new xform, right? This is going to be a handle to the new xform. And that's basically going to wind up being the same thing a bunch of times. So I'm just going to kind of paste this in here real quick. Okay. So from position, that makes sense. From rotation, again, a K handle. Position rotation. Right, okay, so xform parent get. This, instead of doing a xform, is going to take a handle and return a handle. Right? And so in this case, we'd have a handle if not found an invalid handle, right? So we can just check the value of that handle to see what it actually got returned. Returns a handle, right? And then here is going to be a handle. In fact, I think we can probably do a find and replace on pointer, like the word pointer with handle. Whoops, we want pointer handle. Cool. All right, so let's see. Okay. So we have K handle there. Xform position get. So this is just going to be a handle. We don't need it to be const because it's not a pointer anymore. All right, we have parent sets. This also needs to be K handle parent. Right. Let's see. Position sets. So again, K handle translates. Rotation gets. Rotation sets. Right. It's just basically going to be the same thing through and through. Let's see, delete. All right, we don't need a constant handle, right? All right, so we've got that. Okay, we're almost all the way through this file already. All right, cool. So the last thing that we're going to want to add here is a way to actually get a pointer if we need it, right? We should be able to, like, theoretically extract everything that we need from it. But if for some reason we need a pointer, let's see, these are all the creates. Okay, so let's do it right here. So we'll say xform, const xform, xform from handle, and we're going to take a K handle, right? And in this case, returns a pointer, a constant pointer to a xform if one exists for the given handle. Right, and then param t a handle to the xform. Returns a constant pointer to an xform if the handle is valid. Otherwise, null. All right. And there we have it. That's basically what that looks like. All right. So let's see. Okay, you just joined the stream, but what exactly are you working on today? So we are actually performing a bit of a system refactor to get rid of using pointers in a lot of places and favoring handles for those things instead. And that's to get rid of the issues of having stale pointers, as well as to simplify the process of setting up our transform graphs and stuff like that that we need for our scene. And also ads, because ads are a necessary thing in terms of Twitch. So, for those of you who are new or haven't seen this before, we pause the stream whenever ads come up. On the Twitch side, they come up every 30 minutes for 90 seconds, or at least a max of 90 seconds. So we pause the stream so that nobody misses anything. And I will also say that we put a timer on the screen so that you guys can see how long we have left. And that way, if you guys need to go get some water to hydrate, as you should, you have time to go do that. So I like to hydrate during ad breaks. You guys should too. And in terms of the YouTube chat, I see that there's some stuff there as well as on Twitch. So we'll catch up on the chat before we dive back into the code after ads. So we got about 30 seconds left. Almost done with ads. All right, ads are dead. So, Skyward Dev, do you have your Vim RC file anywhere? I can do you one better. I actually have an article that I wrote up on my site that explains everything that I use and why I use it, how it's set up, and it also has a link to my NeoVim setup. So, yes, but also better than that. So I'll drop that link in chat for you. Weird Trash Can, hello. Good to see you. By the way, Manjaro corrupted, and now I'm on Pop! OS. It's doing fine so far. Awesome. Yeah, I think I'm going to give Pop! OS a try as well. I've heard good things about it, especially when it comes to NVIDIA cards. So that's probably the way I'm going to roll, at least for a bit, and we'll see how that goes, right? Because I'm anxious to get back on a Linux machine, for sure. Okay, so what's the API for handle? Is it like an optional? So essentially what a handle is a handle is just a structure. That's this, right? So it has two things. It has a handle index, which is a index into... this says global handle table. That's actually incorrect. We'll say into a resource table, right? So what that means is if you consider a resource such as a mesh or a texture or something like that, this is a direct index into an array of those things, generally held by like a texture system, mesh system, things like that. So by the handle, we can then go into that system and say, okay, what index or what thing are we working with, and get the thing that way. We then have a unique ID. So anything that uses, any system that uses handles will also assign a unique ID to the item that's being created. And that same ID will be copied over to the handle. And the idea there is that if we have a handle out and about floating around, that has one unique ID, and then let's say an object gets destroyed, and a new one is created within that same handle index within that resources array. Like let's say we unload a texture at index 8 and load a new texture in index 8 in the texture system. That would wind up having a different unique ID. So anything that had a handle to index 8 would then say, oh, we have a stale handle because when we ask the system for a texture at that index, its unique ID didn't match, right? And so that's a way for us to be able to say whether or not this handle has gone stale. And so it's a very safe way for us to be able to say whether something truly exists or not based on the combination of these two things without having to worry about maybe a pointer has been freed, or maybe the array during a reallocation got moved to a different section of memory and now all those pointers are invalid. We don't have to worry about any of that stuff with this, right? This kind of gets us around that. So that's basically what we're doing, right? Okay. Bad comic, hello. Good to see you. All right, let's see. Cheers. All right, cool. Yep, appreciate that. I don't know if that happened to you, but your YouTube videos are kind of laggy on Manjaro. This doesn't happen on Pop. I had that issue once on Arch, actually, and it wound up being Chrome's fault because I updated Chrome and I never had the problem again. So yeah, I don't. It also depends on. I think I was also running KDE, which it had problems with too. So I don't think Pop OS uses a Wayland. I think Pop OS doesn't use Cinnamon. I forget. Yeah, using Google Chrome. Yeah, I mean, oh, it uses GNOME. Okay, I couldn't remember. Like I said, I haven't actually used it yet, so that's what I'm going to try installing. Right. I've not really liked the GNOME desktop environments for quite some time, but I'm willing to give them a shot again. It's been a few years. More like Poop OS got them. Yeah, I don't know. I haven't really heard anything bad about it, right? Other than the typical things that you get from people that talk about Ubuntu, right? That sometimes packages are stale and stuff like that. But you miss KDE. Yeah, see, that's what I'm worried about. I do worry about that, but just to use Arch, by the way. Yeah, so I've been using Arch for the last couple of years, but I don't know. Like, I don't know if it's the distribution or what, but the NVIDIA drivers on it have just been absolute rubbish. I had to stop streaming from it because of it, because it just kept crashing, right? And so I was like, well, I've been using Arch for a while. I was due for a new install anyways, so I was like, well, let me distro hop for a little bit and try some different stuff. Whenever you get an AMD GPU, you'll go back to Arch. Yeah, I probably would too, to be honest, but your favorite Ubuntu bug was when the snapd store Firefox was causing my Vulkan driver to crash. Gross. Yeah, the whole snap thing is, I'm not a fan of it at all. That's one of the reasons I don't really want to use Ubuntu anymore. Signer Boy, thank you for the follow. Appreciate that. All right. So I think we have everything here fixed, I believe. So let's write that and go over to here and create a xform system.c. And let's also go to transform.c. And I'm going to grab everything from here down. And plop it in here. And we want to include xform system, right? This should be math, kmath, and then we're going to do the old find and replace again. So we're going to do transform to xform, and then let's see. Our xform creates. Oh, right. I'm going to have to go through and change all of these, aren't I? Okay. So this is going to be a K handle. And for now, I think I'm just going to update these function signatures, and we'll come back to some of this stuff. So these are all the creation functions. We want a handle to the xform parents. We want a handle here. Obviously, we have lots of errors, right? We have to sort some things out with the system. Okay, so handle, and then same thing here. You know what? I think actually I'm going to do let's do xform, if I can spell it right, T. It's got to be escaped, I think. Yeah, there we go. So we'll replace that with K handle T globally. All right, so that should get us most of those. And then we'll also do a const K handle with just K handle. That should get us like 90% of the way there. Okay. So, one thing that we're going to have to set up is sort of our internal system state, right? So we're going to need to type def a structure, and we're going to call that xform system state. Xform system state. Right. And in that, we are going to have a array of xforms, right? So xform xforms, I guess. Right. And I think we're going to go ahead and just do this as a D array. I don't really see a reason not to. Which means we need to include containers D array. And we're also going to have to create a couple new functions here. So we're going to have a B8. You know what? Actually, I should probably copy this from a different system. So let's go to texture system C. Use this as an example. So we basically have this initialize that we need to do. This one might actually be more complicated than we need, but whatever. I'm going to copy these as an example. So we essentially need the initialize and shutdown. Okay. So we'll put this here. We're going to call this xform system initialize. There's the config. I don't think we really need any config for that, so I'm not going to worry about config. Struct requirements. Really, this is the only thing that we're worried about. So actually, we're going to say the memory requirement for this is going to be size of xform system state, right? And we're going to change the rest of that, delete this, right? So we're essentially going to tell the systems manager whenever we stand up the system, we need enough memory for this struct, right? And we're just going to create a D array to actually handle that. So we're also going to need a static state pointer. So that's going to be a xform system state pointer, right? So we set that up. We don't have config. State pointer, we don't need this, we don't need this. Xforms is going to be equal to darray create The type is going to be xform, right? We don't have a hash table. We don't need any of this stuff. I don't think we need any of the rest of this actually, right? So our initialize function is pretty simple, right? We essentially report the memory requirements on the first invocation of it, and then we set up the array on the second, right? And the state pointer on the second. Shutdown is going to be really simple as well. The individual xforms themselves don't have any memory that they allocate, so we don't even need to do this. The only thing that we need to do is do darray destroy state pointer xforms, and then state pointer. Actually, we don't even need to zero that out because we zero this out. Okay. So we'll need to actually take this and move these to the header file. So let's do that real quick. I'll grab this. And we'll go all the way to the top to put this in. So this is really the only thing that this system actually does, is these two things, right? So all right. So we have the system initialize, the system shutdown. So that's going to be basically what holds all of the xforms. These two do not get exported, right? Because they're core to the engine. Anything outside the engine should never be calling these things. And everything else in here should be exported with this KAPI, right? So we have that. All right. So now that we have initialize and shutdown, we basically need to refactor each one of these functions to create a xform and then create a handle for that and return it, right? So let's see. We're doing xform position, rotate, scale, set. So it looks like all of these pass through to that function, which is the right way to do it. And then we're setting the transform local to identity and the parent to null. So we're going to have to change that. Looks like we're repeating that a couple of times. So, I wonder how much of that we should actually even be doing, to be honest. Let's see. Let me catch up on chat for a second here. Hey there. I often pose this question to various folks. Could it be that artificial intelligence might take over the role of game developers, leaving them with two potential career paths, game designer or engine development? No, I'm not worried about that in the slightest. AI is nowhere near the point of actually being able to make stuff that is viable for a production game or production product, right? It just isn't. And that's true not only from a development standpoint, but also a design standpoint. It's nowhere near ready for that. And to be honest, the data that these things are trained off of, which is all in the internet, is full of rubbish information, made up information, flat out wrong information, which is why these things tend to get it wrong, right? Because the training data they're using is half the time wrong, right? Because they're just scraping it off the web, and the web is full of goblins, right? And so, you know, there's lots of misinformation out there about all kinds of things, and AI just scoops that up and rolls with it, right? It doesn't have critical thinking capability, right? So it doesn't know what's actually legit versus what isn't. And so, yeah, I'm not worried about that in the slightest. And that's true for development across the board, to be honest. It's not just game development in general. But that's my take on that. Trashcan, thank you for the hydrate redeem. Appreciate that. I still remember ChatGPT teaching me what's wrong or what's teaching you wrong what's winding in 3D rendering. Yeah, exactly. Yeah. Exactly my point. All right. So, I think probably what we'll do here. So let's see, let me just peek the definition on this, right? So we set the position, rotation, scale, and then the dirty flag to true. I guess that's fine. So let's actually fix that function. Oops. Let's fix that function first. Since it's actually used a lot, right? So, rotation, scale set. This actually has no way to return a failure if we fail to set the thing, right? It probably should. It didn't initially, like in our initial thing, right? But I'm thinking now that maybe it should. Do I really want that kind of an API change though? To check booleans on every single one of these operations, it seems kind of crazy. Let's do if state pointer, right? Because we have to validate that. And then in here, we'll say, instead of t position, right, we'll need to get, let's call this handle. Or let's call this x. Why don't we call the handle x, right? And we'll say transform, or xform, I guess, t equals state pointer xforms sub x. Right, so that's how we'll get that. And then before we do anything else, we will check to see if, you know what, I'm going to switch the t and the x actually, because externally it makes a little bit more sense. So let's call this x. And then t handle index, right? That makes sense. Okay, so if x, x has, let's see, x has, yeah. If x unique ID, which is the underlying number, if that equals t.unique ID, then we can go ahead and do all of this, right? Otherwise, we don't bother with any of it, right? So if this doesn't match, that means we have technically a stale pointer, right? So I suppose we could like warn about that. XReaper95, thank you for the follow. Appreciate that. So we can say k warn stale handle provided. Should we say, let's say xform unique ID mismatch stale handle provided. Nothing was done. Right? We'll just warn about it. I think that's acceptable. Dirty flag is such a present name in engine dev world. I love it. Yeah. I mean, you have to, right? Because that's how else would you know whether stuff's been updated, right? And this is even more of a reason, by the way, to work with handles instead of pointers, right? Because if you had a pointer and you just set this position, rotation, scale and forget to set the dirty flag, that's going to be a bug, right? Versus when you're working through handles and you just set this stuff, it all happens under the hood automatically, right? But yeah, let's see. Does xforms never shrink? You mean the array? No, it will never shrink. So we really have no reason to shrink the array. It doesn't really solve anything for us, right? Those just become essentially empty slots, more or less. All right. So this is more or less the way that things are going to work for, across the board, really. So actually, I'm going to copy this. Actually, I'm going to copy this whole bit. And go back to the top here. In our create. And I'm just going to pasta that right in place, right? So the first thing is, if we have a state pointer, we're going to act one way. If we don't have a state pointer, we're going to bleat about it. Right? Attempted to create a transform before the system was initialized. Right? And I guess what we can do is we'll create a new K handle here. Right? And we'll just fill it out accordingly. So if we're in an error scenario, we'll say handle unique, handle index equals invalid ID, right? And handle unique ID equals invalid ID U64, because I happen to know that's a U64, right? And then at this point, here we would return handle, right? And then this stuff essentially gets moved to here, more or less, right? So we can get rid of this return. And now we actually need a new sort of internal function. So we need to search through the array and find an open entry, right? So what we'll do in this case is we'll have a static function, meaning it's only visible within this C file. Let's get rid of that. And then we will do, let's see, handle create, right? Yeah, that should be good. All right, so you know what? I think I'm going to do a k assert here. I think I'm going to do an assertion on some of this stuff, because if we're trying to create handles before this stuff is set up, then we really need to like slap the programmer, right? So core asserts. Okay, so kassert message. So what we're going to say is there should be a state pointer, right? And the message should be xform system state pointer accessed before initialized. Good enough, right? Okay, so U32 xform counts equals darray length state pointer xforms, right? And then for U32I equals 0, I is less than xform count plus plus I, right? And then we can say if state pointer xforms sub I unique ID equals invalid ID U64. Then we'll use that as our marker to say, okay, we actually have one that's open, right? So found an entry. Oh, and we have ads. Dang, I thought we just had an ad break. Time's flying tonight, seemingly. Let's see. So for those of you who can still hear me, like over on the YouTube side or on the Twitch side, every 30 minutes we're served with 90 seconds of ads. And I like to pause the stream whenever that happens so that nobody misses anything. Long and short of it, right? And so with that, I am going to hydrate, and I'm going to suggest you do too. Have a little bit under a minute, so if you need to get some water, hop up and grab that, right? Rico, over on the YouTube side, how's it going? Good to see you. Welcome. You just got a YouTube ad? I need to see it, like, does it display full screen over on that side? I'm not actually sure how that side of it works, to be completely honest. It does, okay. Yeah, so I hopefully, like, I've tried to time them out so they're kind of the same between Twitch and YouTube, but I don't 100% know how it works over on the YouTube side, admittedly. All right, anyway, we are back. Ads are dead. So in this case, we essentially have found an entry. So we have a couple things to do here, right? So the first thing is we have a K handle to create. So we're just going to call this handle. And so first off, we're going to set handle. Handle index is equal to I, right? And then we're going to say handle unique ID is equal to identifier create, right? And I think that just returns an identifier, right? So this is basically what we're going to do whenever we create a new handle, which is only done internally, right? So we look through here to see which one of these are set up, and then that's kind of how we do it. Let's see. Wait. Oh. If. Oh, I think this needs to be unique ID. Unique ID. There we go. Okay. So we check all of these for unique IDs of U64. As soon as we find one, we consider that an empty slot. So we fill out the handle and update the unique ID, right? So we fill out the handle, then we say state pointer xforms sub I unique ID equals handle unique ID, right? And then we can break. Okay. Actually, we can return at that point. So we'll return handle. No need to progress any further. If we make it all the way down here, then we're going to say k error failed to, actually no. If we proceed all the way down here, that means there were no open slots, but we can expand the array. Right? So no open slots, expand array, and use the last slot. Right? So what we'll do is we'll essentially do something very similar to this. Our handle index is going to become xform count. Handle unique ID, we'll go ahead and create that. And then before we actually set this, right, because obviously it hasn't been added to the array yet, we'll do darray push. The array is going to be state pointer xforms, and the value that we're going to push to it is going to be handle. So we'll push it. We'll push it to the array, and then xform count, which is our new index, will have its unique ID synced, right? So that's that. This also reminds me, though, I need to actually invalidate all of the handles in this, right? So when we do darray create, instead of create, actually, since this is transforms, the way that the darray works is it basically doubles the allocation every time it hits its limit. And so what this is going to wind up being is having like several reallocations all at once very early on. So I actually want to do reserve. And let's reserve, I don't know, 128, right? 128 transforms, right? And that way, we already have 128 set up, ready to go, and we're good, right? State pointer. Whoops, actually, I need darray set length set. That's what I wanted. Xforms state pointer xforms, and we want to do 128. So we're reserving memory for 128. We're setting the length to 128, and then we're going to, for u32, I equals 0, I is less than 128, plus I, right? And essentially we're just going to go through these, state pointer xforms sub I, unique ID equals invalid ID u64. So essentially what we're doing here is reserve space for a lot of these and invalidate them, right? And that should work. That should work just fine, okay? So we basically create enough for 128. We invalidate those 128. Then when we're doing handle create, we'll essentially search through those 128. And then when that fills up, we will push another one onto that, which will double the allocation count, but not the actual length. And then we won't have to reallocate again for some time. So that should cover our bases there. Could be a macro setting, so you can compile with a higher number if you want for your game. So that's actually what the configuration is for, right? And I wasn't actually going to use configuration, but now I'm thinking I probably should. So like this config that's passed in the system config, we could easily put that as a value there, right? And pass it in and then just read it here. In fact, we probably should do that. So xform system h, let's go to the top, and we'll do type def struct xform system config, xform system config, right? We'll have u32 initial initial slot count, I guess. The initial number of slots to allocate for xforms on startup. Right. And then we can go here. And when we do, right before we do this, we will say xform system config type config equals config. And then here we can just do typed config initial slot count, right? Bam. There. That way we don't have to do it in a compile option, right? We can actually set that up in application config, pass that through. We're actually doing that in a few other places anyway, so we could easily expose that to the application config. Would you recommend newer devs to use NeoVim? Does it make you write code faster? I thought about learning it, but it seems daunting, maybe because I grew up on GUI editors. So I'll say this, right? I only switched to using Vim about maybe a year ago or so. And I tried it a few times on and off over the years. Because it is a lot to learn, right? And the only way that I actually wound up getting good with it was forcing myself to use it for work as well. But now that I'm used to it, I am a lot faster with it than I ever was with any GUI editor, for sure. Just because, you know, I do touch the mouse here and move things and highlight things on screen for you guys so that I can kind of point things out a little bit better. But more often than not, my hands never have to leave the keyboard ever for things. And that dramatically increases, at least it dramatically increased my speed, right? So I would say give it a try. Don't be surprised if you go, man, this is overwhelming and, you know, I'm just going to go back to VS Code or whatever. But, you know, give it more than one try, I would say. You know, do what you have to do in VS Code when you need to work fast. But certainly if you have the time, I would recommend at least giving it a shot, right? I'm not going to lie, though. You know, there is a lot to learn with Vim. There's a lot of keyboard shortcuts and Vim motions and learning how all that works, as well as the config, right? So, yeah, you're going to spend a lot of time tweaking it and modifying it and trying to learn. And how do I look up how to, you know, or how do I do X in Vim, right? So there is going to be a lot of that kind of stuff, but I think it's worth it. Okay. So that's our initialization. All we need to do is destroy that. Okay. So we have handle create. We also need to have a handle free, right? For when we actually destroy. Do we actually have a destroy X form? I don't remember if we do. I don't think we do, but we probably need to. We do not. And the reason we didn't before is because we were dealing with raw pointers, right? But we probably ought to have one. Okay, so let's do after all these froms, which are essentially, you can think of them almost as like constructors, right? Let's do a void xform destroy, and we'll do a k handle, right? And then before we fill that out, actually, before we do anything, because I'm going to forget to put this in the header file. Let me do that first. Let's see. Okay. Oh, and you know what? I forgot the from handle as well. So I need to copy that back and implement that on the other side as well. So we're going to export this. And this guy, whoops. This guy is basically destroys the xform with the given handle and frees the handle. And I think there's going to be a lot of places in code where we're actually not destroying transforms, and we should be. That's pretty much it for that one, right? We can say param t a handle to the transform to be destroyed. All right. So that's that. I need this guy because we actually need to implement that down here. Right. So we'll say if not state pointer return 0, right? And then otherwise we'll say state pointer if state pointer xforms sub t handle index. Let's actually grab a pointer to that. So I'm going to say xform x equals address of this, right? But then before we return that, we're gonna do some validation. So we're gonna say if x unique ID unique ID is not equal to. Actually, let's go with equal to first, right? So if that is equal to t unique ID, then we have a match and we can return x. Else return 0. So we want to validate that the handle is not stale. Before returning it. If stale, don't return it. We can also we'll say xform from handle was provided a stale handle. Nothing will be returned. So at least if we run into that, we know why, right? Okay, so we've got that. Our xform destroy is going to need to call the function that we haven't set up yet. So we need to go ahead and set this up. So where was that? Here. Okay. So it's going to be another static function. In this case, it's going to be void. And we're going to say handle destroy. And we're going to take in a k handle, right? And we're basically going to destroy the thing. So let's do this. So we're going to assert that the state pointer exists, and then state pointer access before initialized. That's fine. And then now we can actually say, let's see, if state pointer. Actually, we don't even need to check anything. We can just destroy it, I think. Yes. Okay. So state pointer xforms sub t handle index. And we're going to say unique ID equals invalid ID u64. We should actually do if t handle index is not equal to invalid ID u64, then we'll do this, right? Because we don't want to use an invalid handle index. Should we take a pointer to that handle? I feel like we kind of should. I feel like we should because we want to actually clear out the pointer itself, right? So let's do that. Handle index. Oh, that should be invalid ID, not invalid ID U64. There we go. All right, so we check that, and then we invalidate the handle itself. So we can say T handle index equals invalid ID, and then T unique ID equals invalid ID U64, right? And that pretty much destroys the handle. Do we have one more thing I want to check? So I don't think identifier. No, we don't need to destroy the identifier. Right. Okay. All right. So we have our handle destroy. So when we do a xform destroy, the first thing that we're going to need to do is if state pointer. And since this is return type void, because that's a destroy, if we can't do anything about it, there's not really any purpose to bleating about it, right? We'll just kind of do the thing. Xform destroy should probably take a pointer to the handle, though, as well. Because we're destroying it and we need to actually update it, right? So to a handle, the handle itself is also invalidated, right? That's probably a important bit there. So we can now say if T unique ID, oops, not unique ID, we want handle index is not equal to invalid ID, then we can say state pointer xforms T handle index unique ID is equal to invalid ID U64, and then T unique ID is also equal to invalid ID U64, and T handle index is equal to invalid ID. We should also check that T exists. Okay. So creation and destruction of these are handled correctly now. Pardon the pun. All right, let me catch up on chat here. Let's see. I tried to learn Vim 3 times before something about NeoVim finally stuck for me. Yeah, the Lua configuration helps a lot, right? W NeoVim. Yeah, XZcraft, thank you for the first time chat, and welcome, by the way. Spiro, you're lurking, but I dig some of the cool stuff you have in your background. Ignore me. Keep going. Some of the cool stuff I have in my background. Like my... Do you mean like my wallpaper? Let me move this out of the way. Is that what you mean? Oh, you're talking the camera background. I gotcha. Okay. I was confused for a second. Yeah. Yeah, there's, in fact, it's kind of a mess at the moment, but I'll briefly blow this up so you guys can actually see, like, all the random stuff I have. So I actually have, a whole bunch of figurines back that way, which are kind of out of camera view, unfortunately, but maybe I'll show that at some point. I've got a whole bunch of games up there, a whole bunch of figurines here, a bunch of random stuff there, an Oculus, all my programming books and my Japanese books and stuff like that. So all kinds of random stuff. Pictures of my animals. A Vivi light up thing over there. I need to actually plug that in. Random records, and then a little cask there that has pineapple whiskey in it, which is amazing. But yeah, all kinds of stuff. I knew you were a cool dude doing C. Now you're a super cool dude. I appreciate that, man. Yeah, one of these days I'll have to like do a like a show of this cabinet that's over here, because it's got all kinds of cool stuff in it, but this light's kind of in the way, and it's like I can't reach my camera over there, so I'm gonna have to figure something out. But one of these days. Are you on Windows 10 or 11? I'm on Windows 11. Let's see. Hey Praveen, how's it going? Anything exciting happening in your view in Vulkanized 2024? To be honest, I haven't looked at it yet, which is terrible. I need to actually look into that and tune into that and see what's going on, because I just haven't had a chance to actually look into it yet. Still thinking about how clever this handle idea is. I mean, I can't take credit for it, right? Like, there's lots of game engines that make use of it, right? The way we do it here is a little bit specific to the way that this engine does it, but it's not an original idea, not in its entirety, anyways. But I think it's going to work pretty well, right? All right, so let's concentrate now on trying to fix some of these errors that we got, where we need to actually look up our handle, right? You know what? Don't we have... So we can actually use this X form from handle to our benefit. Because all these functions are basically going to have to do that lookup, right? So, with the exception of the create functions, I guess. So, xform creates, we're going to have to do, how do we want to do this? So, handle is going to be equal to handle creates. Right, so that should reserve us a spot in the array and update the handle, or give us a valid handle, right? So we have that. Then we need to do we need to get the xform from the xforms array. This is going to be handle index, and then let's see, what is this here? So this takes a handle to do this, which is going to have to look up the handle again. So I'm actually not thinking we should be using this function to actually handle this. No pun intended. I think we're going to set these things manually, because otherwise we're going to have to do another lookup, because this function now takes a handle. So we'll do... I guess, yeah, we'll just do position equals vec30 x rotation equals quat identity, right? Because we're using quaternions. and then scale equals vec3 1, right? Because we don't want a scale of 0, we want a scale of 1 by default. And then we can say x I guess we can do x local equals mat for identity. And actually, we can set the dirty flag to false on this one because we actually don't need to. An identity matrix is 0 position. Oh, an identity matrix is adds, actually. We were mistaken. So we've got 90 seconds of ads. 90 seconds to go hydrate if you haven't already. Strongly suggest you do. I'll give my voice a break for a minute too. So we got about 30 seconds of ads left. A little over. Almost there. All right, cool. Ads are dead. So, thinking about this a little bit, it might be nice to have a couple of convenience functions for our handle here, right? Because we have, when we are doing creation, right? When we're creating a handle, we are essentially always going to be setting the handle index, always going to be doing a identifier create, and then we can take that unique ID from the handle and copy it to whatever we're using, right? So it might be nice to actually encapsulate this as well as the creation of an invalid handle into a couple functions, right? And those would probably belong over here. Just so that we don't have like this all over the place, because this is a little bit error prone, right? Whereas we could just say, maybe k handle create and then pass a handle index, and then it automatically does this identifier create bit. And then we could also have like maybe k handle create invalid, right? And we can use that as well. So let's do a k API. And we'll say k handle is a return type, and we'll do k handle create, and this will take a U32 handle index, and then we'll have a k API k handle invalid, right? And that won't take anything. And so for this guy, creates and returns an invalid handle. Simple enough. And then this one creates and returns a handle with the given handle index. Also creates a new unique identifier if I can spell it. Okay. And then maybe, so we have creates handle invalid. We could also have a B8 where we can say K handle is invalid, right? And what we do here is we take a K handle and brief indicates if the provided handle is invalid. Right? So we can take these three and snip them in here. Right? I'm actually going to do away with these. I don't think we're going to need that table, right? I think we're going to have to sort of implement that individually for each system that uses it, and I'm actually kind of okay with that. So K handle, out handle, right? And we'll say out handle dot handle index equals handle index, and then out handle unique ID equals identifier create, right? And then we can return out handle, right? And so this invalid is essentially going to do the same thing with a couple of key differences. This is going to be invalid ID, and this is going to be invalid ID U64, right? And this unique ID dot unique ID needs to be set that, right? So we've got that, and then here for the handle is invalid, we can return handle index invalid ID, or handle unique ID equals invalid ID U64, right? So that way that stuff is all easily accessible here. I'm going to nuke this table stuff because I don't think we're going to use it. Oops, I nuked the end if I need that. Okay. So, instead of having to do this identifier create stuff here, we've found an entry. So all we need to do is say handle equals K handle create, right? And then pass I as the index, right? And then for down here, we can also do the same thing, but instead of I, we use xform count, right? So we can get rid of that. There we go. Nice and simple. Handle destroy. You know what? There's actually, we should probably encapsulate this into a function too. So let's do one more function. KAPI. We'll just do void on this one. And we'll say K handle invalidate. And this will take a pointer to a handle. Right, so we can say brief validates the provided handle. All right, so put that here. So if handle just grab these two lines, plop them here, do handle, and there we go. So over here, now we can just say, let's see, k handle invalidate, and pass over t. Right? That way, no matter where we're doing this from, it all runs through the same logic. We don't have to worry about inconsistencies, or if we have to refactor this for any reason or add additional data, it becomes very easy. Okay. So in this case, back to our creates, we go ahead and get a pointer to the xform using the handle that we've just created. We set the position, scale, rotation, local, and is dirty. The only other thing that we have to set, and the reason I started creating those functions, is parent equals k handle invalid, right? Because we want an invalid handle for that. And now we can do that, right? Now we don't actually have to do this validation here because we just created the handle, right? So we know that's going to match. So this can all go away, right? So we have xform creates, we create the handle, we fill out the xform by obtaining a pointer to it. Otherwise, we need to say our handle equals k handle invalid. And then either way, we return a handle. And that's basically the pattern that we're going to follow. I've got to do this adds things too. I like it. Yeah, I picked it up from Thor, actually, and I thought it was a really clever idea, especially when he's, talking about something important or programming or something like that. I think it's a really good idea, and I don't think enough streamers do it, right? Yeah, I think it's a fantastic idea. So I kind of just picked that up and rolled with it. It's obviously worked well for him. So why not, right? Okay. So from position. So this is basically going to be the same exact thing. And as much as I hate repeating myself, I'm going to do it here because not doing so and passing this through to another function causes another lookup. So the only thing that we have to do here is just change this to position. And that's it. Same thing is true for the next one. Oops, actually I need to grab this one. Ah. Yeah, okay. So we need this, and we need to do from rotation. And so position is going to be the default this time, and this time we're going to take rotation. And then we have position and rotation. So that's just going to be this same thing, except we're going to take position and rotation. All right. And then position, rotation, and scale is going to be the same thing again. Oh, you know what? There's actually something I need to fix. So xform from position, the dirty flag needs to be true because we're going to need to recalculate the local, right? Same with rotation. And same with this guy. basically the default create is the only one that doesn't have to be updated. So let's grab this. So from position, rotation, scale. This one is going to take scale. Right? Okay. So xform destroy. We take the handle in. Okay, and here we were doing the destroy, but actually what we need to do is set unique ID. Actually, do we do that in... Do we do that in handle destroy already? We do. Okay, so we can just actually call handle destroy on that one. So technically what we can do actually, we don't even need that, right? We can literally just call handle destroy and pass T. Easy. Easy peasy. Xform from handle just returns a pointer. We already have that filled out. Parent get. Okay, so in this case, we actually want the handle of the parent, which means we're going to have to create a handle based on the current parent. Okay, so that means we're actually going to need another function over here. So we actually need a we need a handle k handle create with with identifier, we'll say. So we need a U32 handle index and an identifier ID. And this is basically going to create a valid handle to an object that we already have within our state, right? So let's actually do this in one line. Creates and returns a handle based on the handle index and identifier provided. And this is not going to do any sort of validation. It's just going to kind of do it, right? So we can do this. And the difference here being that instead of doing identifier creates, we will take the ID that's passed in and use it instead. Right. Okay. So over here, I think the easiest way to do this is probably going to be to actually get the xform of the parent, right? So we'll say, first off, if T, actually we could just say if not invalid, right? So if not k handle is invalid, right? And then we pass T. So if we have a valid handle, then we can say const xform pointer x equals xform from handle, and again we pass T, and then if x, then we do a k handle creates with identifier, passing oh, wait a minute. Wait. got ahead of myself here. So if we have x, x is actually the handle of the current, or is the x form of the current handle passed in. So we actually need to get its parent, right? So current x form exists, get parent. So we'll say if k handle, whoops, not k handle is invalid, and we'll say x parent, right? And so if the parent handle is valid, then we'll do const x form parent equals, and we can do state pointer. I guess we could actually just do x form from handle, and that's going to be x parent, right? So we have a pointer to the parent, if we have a pointer to the parent, rather. Then we can say k handle create with identifier. And then we say x parent handle index. Actually, we don't even need to get this, do we? We don't even need this, actually, because we actually have the parent index, right? I'm so used to thinking about pointers that I actually almost did something I didn't need to do there. So in this case, we already have we know that the parent handle is valid, right? We've already checked that. So now we can just say we create a... No, we actually don't even need to do this either. We can actually just return x parent. And that's literally the handle that we would need. So if for some reason we fail at any point in that, we would return a k handle invalid, right? So invalid handle or parent not found does not exist, right? So there is our parent. Dopinder96, thank you for the follow. Appreciate that. Welcome. All right. So we basically just have to set a lot of properties here. So we're actually almost done with this, right? So this is the first system, and honestly, this is probably the system with the most function calls, except maybe this texture system might be the only other one. So the advantage of doing this system separately like this is, like, when we go to do the other systems, we can kind of convert them to use X forms instead of transforms along the way. So we have X form parent set. So we're essentially going to want to do a similar process with this guy, except we don't need to return a handle, right? So we can actually do... We could do this. If the handle is not invalid, and that's the handle that we're setting the parent for, then we can go ahead and get... You can go ahead and get that from the handle. Check to make sure that that actually exists. And then, technically speaking, we would just do X parent equals parent. Why is that not? So that's a K handle, which this is a K handle. Const qualified type. What's const qualified? Oh, right. Xform from handle is const qualified. And this is the exact reason I did that, right? Because we don't really want to be taking pointers and modifying them. So this is exactly why I did that. So what we'll do is, if the handle is not invalid, then we'll just do, we'll do this. And then instead of doing this, we'll say state pointer xforms sub t handle index. Right? And we're going to want the address of that. That'll give us what we need. Right? So we can set this parent to whatever it is. This parent can also be an invalid handle, and that's okay. That's basically saying unparent this thing. So that's fine. Okay, so xform position get. We're going to basically do... We're going to do actually this. We can use this. Right, we'll say here, if we are able to select the xform from the handle, then we'll return x position. Now I suppose we could return... We're going to have to return a vec30 here for this, right? But let's warn about it. Invalid handle passed, returning 0 vector as position. Right, so at least we get some warning in the console that that's happened. I think that makes sense. So what we're actually going to do is there's a few of these getters, quote unquote. So we're just going to use the same thing and just return like rotation. This is going to have to be, oh, you know what? Let me do scale and come back to this one. Right, so scale, returning 1 vector as scale. Oops. Okay. And then up here, we're going to do a returning identity vector as rotation. And this is going to be quad identity, right? So that's that. Guess we can cover the rest of those in a minute. Let's see. I like the Yar cult emojis there in chat. Thank you for that. All right, we're going to have ads here in just a second. While I think about how we're going to handle the setters, which is not going to be a big deal. So I think for the setters, what we're going to wind up doing, essentially, is we are going to do the same lookup. And then instead of doing the from handle function that we're doing here, we'll do a direct lookup into the array and update that entry. And I think that should be sufficient. So let's copy this and then break for ads. I knew they were coming up sometime shortly. So for those of you who are new to the stream on either side, we like to pause the stream whenever ads come up. Obviously you might be seeing ads right now, but we like to pause so that nobody misses anything. So those of you who are not getting ads, just kind of bear with us. It's only 90 seconds, right? And then we'll be right back to it. Also, if you haven't already, go get some water. Hydrate. Hydration is super important, right? We don't do enough of it. I know I don't do enough of it. So honestly, the ad breaks are a good reminder for me to go get some dang water, right? Or at least, reach over and get water in my case. All right, almost done with ads. All right, cool. Ads are done. So let's knock out the rest of this real quick. So we have this position get. I want to do this position set, right? So we want to make sure the handle is not invalid. And then instead of doing this, and we're not going to get a null from this, right? What we're going to do instead, I think I'm just going to change this all to state pointer xforms sub t handle index position equals position, right? And then we'll say invalid handle passed. Nothing was done, right? Don't need to return anything either. Okay, so let's do the sets real fast. So we'll do the scale set. So we have scale, and then we have the rotation. Rotation equals rotation. Cool. All right. So the next one is going to be the translate, which is really just a add to what we already have, right? You know what? I just realized though, on these setters, we also need to set the dirty flag. All right, I'm going to rewrite this slightly. So we're going to say xform x equals address of. Address of this. And then x position, and then x is dirty equals true, right? Because if we don't set that dirty flag, the transform is not going to be recalculated, and it's going to be wrong, which we don't want, right? So let's grab this as well. Paste this here. Let's see, set, we'll do here. So that's a rotation set. Scale set is down here. Right. And then here we'll just do X scale equals scale. X rotation equals rotation. And I think, did I already do position? No. Okay. Did I do it up here? I did. Okay, so position is that, dirty is true. And so what we really need to do here is we need to say X position equals vec3 add. And we're going to take X position and add position to it, right? Because the translate is different than just a set, right? This should be translation. Okay. Get rid of that. Okay, so the translate, that's the pattern for the translate. The rotate is going to be similar. In fact, I'm just going to copy this actually. Right, so let's take this, put this up here, and we'll say X rotation is equal to X rotation multiplied by rotation. And then we'll get rid of this, right? That's the rotate. The scale set is going to be almost the same thing. Right, so the scale, when we scale something, we multiply it by that scale. So we need to set the X scale multiplied by scale, and then get rid of this. Right? Okay, so all of these are setting the dirty flag for the setters. Okay, we're good on those. Cool. All right, so position rotation set and then position rotation scale set. So let's see, we have that, and then we have translate rotate. Okay. So some of these are largely going to be, like, we're just going to have to rewrite some of these, I think. Position rotation set. So I think what I'm going to do here is I'm going to grab the rotation set logic. And go back down to here. And we'll set the rotation, but we're also going to set the X position equals position. That's that one. And then we have position rotation scale set. So this is likely going to be, I think, the exact same thing. Right. And so in this case, we're going to do scale equals scale. Oops. Okay. So then we have transform or translate rotate, which is basically going to be a combination of this one. Oops. Right. And then the rotates which is, which one? It's up here somewhere. This one. We need this line. There. Translate, rotate. Okay. So there's that. And then we have local get. We take a handle to that. So again, we're going to need Master Snoods with the 2 community gift subs. I appreciate that very much. Thank you. I really appreciate the all the support you've given me. It means a lot. Thank you very much. Very, very much appreciated. Because the good thing is I can take all of that and eventually roll it right back into this, right? For example, when we get ready to port this to the Switch, which is on the roster at some point, right? This will help with that. Okay. So we have the local get. So this is actually what... So this, the local get and the world get, are what actually performs the update on the dirty flag, right? And these are the last 2 things that we have to put in place. However, I did actually just think of something that we've missed this entire time. Something I actually just nuked in one of these. So we are missing the bit where we're doing the validation that the handle is not stale. Right, so we probably ought to handle that as well. But we'll go back and do that. We'll get this working first, or at least we'll get this straightened around, and then we'll go back and add all that in, because I think it's probably going to wind up being mostly the same code, just dropped kind of into this line here. So let's go ahead and take this. And we'll say if X is dirty, then we want to take the X rotation, the X position, and then multiply those together, and then multiply that with the X scale. And then update the X local and the dirty flag for X. And then we will return X local. Otherwise, we will return mat4 identity. I feel like I'm missing a brace here, but maybe I'm not. Nope, I guess not. Okay. So we need, again, these guys. Right, so xform local get. Oh wait, we do need the handle for that, so that's fine. We need the x parent. And this one, we need to say if not k handle is invalid. Right, that's how we'll know whether or not we actually have a parent. So if we have a valid handle to the parent, then we'll do the xform world get on the parent. And then multiply that against the local. Take off the determinant and save that to that xform as well and return it. Otherwise, if there's no parents, we will recalculate the determinant anyway and then return the local. Otherwise, we'll return mat4 identity. Okay, so I think that all makes sense. And I think that pretty much completes our rewrite. Yeah, no errors in the file, which is awesome. Okay, so the thing that we need to actually think about now is, let's see, when we are So these creation ones are all correct. I'm not worried about those. It's mainly where we have to get something to update it or get a value from it. So xform from handle does the uniqueness check. So anything that uses xform from handle, we are good with. Xform parent get does not do this. So this really should be if x and x dot unique ID equals t unique ID. Otherwise we return invalid, right? So we need to check for a stale handle as well, essentially. So I think anything that is essentially doing that should just be able to perform that same check. Right? So anywhere we have if x, we should be able to do this. Okay, so this position set is not doing it, so we actually have to do this. Which we know x is going to exist in this case. Right? So we do that, and also we should return early here, because otherwise we're going to do this logic and then wind up down here and throw a warning when it was actually valid. So we have that. Non-fat burrito, thank you for the follow. Love the name, by the way. Welcome. Welcome to the stream. Oops, just return, not return true. Okay. So we'll validate against stale handles there. Here we have to say if x and, so there's another one of those, which is actually all the getters. So let's do the getters first. That way we can know for a fact that they're all good to go. Okay, and then we'll come back and do these ones. All right, so these ones that aren't doing the check there, we have to do it here. All right, so we basically just need to do this everywhere else. So here, oops, just return. Okay, that's the getter. Same thing here. Same thing here. And here. Okay. Almost done with this, actually. Unfortunately, there's not really a better way to handle this, right? Okay. So this one we need to actually think about for a second, these last two. So if we have a valid handle, the next thing that we need to check is to make sure that it is not stale. So we'll put this here before we even check the dirty flag. And wrap that here. Okay, so if it's a stale pointer, it's going to fall through to the mat for identity, right? So we could do a k warn here. Xform local get was provided a stale handle. Nothing was done. All right, we can at least warn about it, right? Okay, that should be fine. So we'll take this and also do this down here. So here, where we're getting the Xform, we need that check. So we'll wrap that. Paste a copy of this message down here too. And we'll say world get was provided a stale handle. Nothing was done. Let's see. Okay, I think we're good. I think we're good. So that's the new Xform system. The last thing, I guess, is to quickly tie that into the systems manager. So we want this one actually in pre-boot. This one needs to be like one of the first things stood up. So we have memory first, that has to be first. Console is set up next. I'm thinking we need this even before the console, right? Because this is like a... No, we don't need it actually that soon. Not for Xforms. Let me think about that. So console, kvars, events, logging, input, platform, resource system. Yeah, it needs to be before the resource system. I don't think we handle anything having to do with resources before this. So we're going to do Xform system config sys config. All right. And we're going to do Xform sys config. And we're going to set the initial slot counts to our sort of pre-configured 128. To do expose to app config. And then we'll need a call to this. We don't have a system type for this, so we'll need to add that. Actually, do we have... Because I was thinking about making a transform system at one point. Do we have one in here? We do not. We do have this renderer view, though, that doesn't really exist. Let me see if I can leverage that. Case system type render view. Nope, that's the only place it exists. Okay, so I'm gonna gonna hijack this one because it's not actually being used anymore. It's an old system. And I'm gonna say xform. So we can say xform here. Right, and we're gonna do xform system initialize. Oh, I don't need all of this. Right, xform system shutdown. We don't have an update, and we don't have whatever the other one was, I forget. But we only have initialize and shutdown, so that's fine. Oh, you know what? We probably should have an update, though. Because once a frame, we are going to need to perform updates on that. All right. Let's do xform system config for that. Do we have an update in here anywhere? I don't think we do. I think there was only like 1 or 2 systems that actually have an update. The job system has one. Just need to steal the function definition from it. Come on. Let's see. Let's get rid of that. Xform system. Go here to the top. And put it right here. All right, so this is going to be xform system updates. Struct frame data, we're going to have to forward declare. Frame data. Okay. So we have this one. We also don't need to export that. We do need to implement it. So let's just put this right here for right now. With a big old fat to do. So my thinking there is that we are going to eventually want to batch all of these transform updates so that they all get updated once per frame. So that way we don't have to have all these sort of world transform get calls all over the place and stuff like that, right? We basically just can use that once per frame, and then we can know based on how we do them not to update essentially multiple transforms at once per frame. Or I should say update the same transform multiple times per frame, if that makes sense. Okay. We're going to leave that for right now, though, because I need to go back to here. And finish filling this out. So we have case system type xform. This one needs to be xform system update. Oops. Okay. So we can then say failed to register XForm system. Okay. So that system's in place. I highly doubt this is going to build right now because I'm pretty sure I've broken stuff, but let's try it anyways, just for... Oh, okay, that's actually an easy one to fix. That's a my bad moment. Needed a void there, and also need a void here. Did it again. Okay. It's the hype train song. Let me see. I guess I can search for... Nah. Let's do handle create and handle destroy, right? Because I know that those are missing this. Destroy is not missing it, actually. Yeah, maybe that was the only one that was missing it. I'll be dipped. It actually built. Okay. Did not expect that. Let me see if it runs. It runs. It does the thing. Okay, cool. So those of you that were curious as to, you know, kind of what we have so far, you know, we're still building things out, obviously, but we have the ability to load meshes in. Our loading system is multi-threaded. And we have, you know, some basic PBR lighting in place with shadow maps and all that kind of stuff. Still very much a work in progress, but there you have it, right? Okay, so let's take a look at this to-do list. So unique per system handle for each. Okay, so we actually do have this. So we have that, and we also did that one. So the next thing is going to be basically to remove the transform from mesh, and actually we should probably have as a separate work item. As a separate work item, we should also do replace any and all transforms, if I can spell correctly, with XForm handles. So that's going to be interesting. That in and of itself is going to be a big work item for sure. I may even wind up doing that one off camera. We'll see. But yeah, so we did accomplish a couple things tonight for sure. Right? We actually ticked 3 things off those boxes, and those are decently sized items. So let's also look at changelog. So we're going to add something here. Created XForm and XForm system to replace transforms, right? And then actually after that, or right before it rather, we added a handle added handles to be used in place of raw pointers. Systems need to all, I should say, resource systems, i.e. materials, textures, meshes, etc., need to be converted to use this. All right. So we have that. All right. And status. So these are all the files that we changed tonight, which doesn't seem like a lot of files, but it was actually quite a lot of work, right? So we'll do commit. Added. Added handles, xform, and xform system. All right. I guess I've already pushed this branch up, so I should just be able to do that. And it's pushed. So this branch is available for you guys if you're interested in looking at it. It's on the actual repo. Cotton Papero, first time chat, welcome. Forsen? I'm not sure what you mean. Not sure what you mean by that. IO, good morning. Hello, good morning to you. It's night here for me, but good morning to you. Ezra Weller, it's been a while since you tuned in. Xform is just a transform type with a funny name. Yeah, so what we're basically doing is we built in a handle system, and that handle system is going to be used instead of raw pointers everywhere. And so Xform is a transform. It's identical to transforms, but it uses handles to operate instead of raw pointers to transforms. So what we're going to do is because so many things use transforms, we've called this Xform. And we're going to essentially deprecate transforms until we get all of the systems converted over to use Xforms, and then we're going to remove transforms. And so Xform is basically just kind of another way to say transform, more or less. And then we may rename that back to transform at some point afterwards. This was just a way to be super clear about like where we're using Xforms versus transforms. It's basically the difference. Sam Davis, hello. Welcome. So yeah, with all of this said though, I think we are just about at the time to call it quits for tonight because we've actually done a lot of stuff here. I think we've accomplished a lot. Pretty successful stream. Agcovio, thank you for the follow. I appreciate that. Speaking of follows, I would encourage you, if you haven't already, to follow me on Twitch or YouTube or both, ideally, because it helps me grow the channel, right? So if you guys like what I'm doing here, I would encourage you to follow me in those places. Of course, I also have social links here where you can kind of get all of my links. It's just a link tree. I decided that's better than just, jamming 8 of them into the chat or whatever it is. So feel free to follow me on those places as well. And yeah, we are pretty much done for the night. So I'm just going to do a raid real quick. And I think tonight, because I usually try to do this at least once a week. So tonight I'm actually going to raid Ferret Software. And that is because it is a ferret rescue that is completely powered by the ad revenue of the Twitch channel that we're about to raid. And the ferrets that are in this rescue were taken from near-death situations. They were basically in line to be put down. And essentially, they are medically rehabilitated and given a permanent home there. They're not rehomed or anything else. So I think it's a fantastic thing to support, and I like to support it every chance I get. So with that said, I really appreciate you guys joining me here tonight, and I will see you guys on the next stream. And over on the YouTube side, I'll post you guys a link to Ferret Software here in just a second. So anyways, thank you guys, and I'll see you next time. And for the YouTube side, if you guys are interested in that, there you are. All right. So with that, yeah, I'll see you guys later.